We need to obtain the derivative of this given inverse tangent function. To begin with, let's state a formula. So let's say if we have tangent inverse of x and we add it to tangent inverse of y, then this will be equals to tangent inverse of x plus y divided by 1 minus xy. Now what we'll do, let's say x is equals to a and y is equals to x. So here we're only going to substitute x with a and y with x. Then in our case, we have tangent inverse of a added to tangent inverse of x, which means it will be equals to tangent inverse of, so in place of x, we have a, plus in place of y, we have x, divided by 1 minus x times y, which is simply a times x. So that means we have exactly obtained our original function. So that means we can rewrite derivative with respect to x of tangent inverse of a plus x divided by 1 minus ax as derivative with respect to x of tangent inverse of a added to tangent inverse of x. Right. So let's find out the derivative. Now we have derivative with respect to x of tangent inverse of a plus derivative with respect to x of tangent inverse of x. So tangent inverse of it, it's a constant. That means our derivative will be 0, and derivative of tangent inverse of x, that's a standard value, 1 over 1 plus x squared. So this is the final value of our given derivative. Problem number 2. So here we need to obtain the derivative of the given inverse tangent function. So let us begin. Here we will consider y to be equals to tangent inverse of a times cosine of x minus b times sine of x divided by b times cosine of x plus a times sine of x. So let's label this as equation number 1. So what we'll do, we'll try to simplify the expression, the given trigonometric expression, by using some transformation. So we'll start with the expression given within the parentheses, and our goal will be to make it into some tangent function. So let's begin. So here what we'll do, we'll consider a to be equals to sine theta and b to be equals to cosine theta. Then, so in place of a, we have sine theta. So this will be multiplied to cosine of x minus b. So b is cosine theta. That will get multiplied to sine x. Whole thing will be divided by, we have cosine of theta times cosine of x plus a, which is sine theta multiplied to sine x. Now, what we have here is a formula. So this is the sine theta plus cosine of x. Well, here we can replace it with sine of theta minus x. And divided by, in the denominator, we have cosine of theta minus x. So what we have done here, we have made use of the fact that whenever we have sine of a minus b, that's given by sine a times cosine b minus cosine a times sine b. And if we have cosine of a minus b, that will be given by cosine of a times cosine of b plus sine of a times sine of b. So in a case, in both the two cases, we've considered a to be equals to theta and b to be equals to x. And when we do that, we'll get the expression this as given by this particular expression. Now, the ratio sine over cosine, that's a tangent function. So what we have done, we have successfully converted our given expression within the parentheses into some tangent form. Now what we'll do, we'll substitute this value back into equation number 1. Number 1 will now become y equals to tangent inverse of tangent of theta minus x. So that means y will be simply equals to theta minus x. I will have to start with theta also. We considered a to be equals to sine theta and b to be equals to cosine theta. So if we divide a with b, then this ratio is sine theta over cosine theta. So that means a over b is equals to tangent of theta. So if a over b equals to tangent of theta, from here we can say that theta must be equals to the inverse tangent of a over b. We will substitute here, so y will be equals to tangent inverse of a over b minus x. Now we can take the derivative on both sides with respect to x. So we have derivative of y with respect to x equals to derivative with respect to x of the inverse tangent function minus derivative with respect to x of x. Now here a and b are both constants. That would mean that inverse tangent is also a constant. So our first derivative will be 0, and that leaves us with only the second derivative, which is 1. So that means we have negative 1. Therefore, the value of the given derivative is equals to negative 1. Let's move on to the next problem. Problem number 3. We need to obtain the derivative of the given inverse tangent function. What we'll do, we'll begin by considering y to be equals to tangent inverse of 3a squared x minus x cubed whole divided by a cubed minus 3ax squared. Now, we'll try to simplify the expression tangent inverse of this particular expression by using a trigonometric transformation. To do that, all we have to do is we will suppose that if we consider x to be equals to a times tangent of theta such that 3a squared x minus x cubed divided by a cubed minus 3ax squared. So this becomes equals to, so we have 3 times a squared multiplied to x. X is a times tangent of theta minus x cubed. So x cubed will be a times tangent of theta whole cubed divided by a cubed minus 3a times x squared. So x is a times tangent of theta whole squared. So this will give us 3 times a cubed times tangent of theta minus a cubed multiplied to tangent cubed theta divided by a cubed minus 3 times a cubed times tangent squared theta. So what we can do, we can immediately factor out a cubed from both the numerator and the denominator, which leaves us with 3 times tangent of theta minus tangent cubed theta whole thing divided by 1 minus 3 tangent squared theta. Now luckily, this is actually tangent of 3 theta. The tangent of 3 theta when expanded gives us 3 tangent of theta minus tan cubed theta over 1 minus 3 tan squared theta. So that means whenever we make that particular transformation x equals to a tangent of theta, then the expression within the parentheses of equation number 1 becomes tangent of 3 theta. So that means our equation number 1 now converts to y equals to tangent inverse of tangent of 3 theta. Right. So that means y will be equals to 3 theta. Since we considered x to be equals to a times tangent of theta, so that means x theta must be equals to the inverse tangent of x over a. That means our y value is now given by 3 times tangent inverse of x over a. To find out the derivative, what we'll do, we'll take the derivative on both sides with respect to x. So that will be equals to 3 times derivative with respect to x of the inverse tangent of x over a. So that means we have 3 times. Now what we do, we'll use the derivative of the inverse tangent function. We know that derivative with respect to u of tangent inverse of u is given by 1 over 1 plus u squared. So here we'll use this formula to get 1 divided by 1 plus. So here u is x over a. So we have x over a whole squared, but we'll need to use the chain rule. So that means we have derivative with respect to x of x over a, which gives us 3 times a squared divided by a squared plus x squared. Now here 1 over a is a constant, so we can pull it out of the derivative. This will be multiplied to derivative of x with respect to x. So therefore, finally we have obtained the derivative of y with respect to x, that will be equals to 3 times. So 1 away from the numerator, 1 from the denominator goes away. So we have 3a divided by a squared plus x squared. Here derivative of x with respect to x is simply equals to 1. So this is the value. Let's move on to the final problem. So here we have to obtain the derivative of the given inverse tangent function. So let's begin by considering y to be equals to tangent inverse of square root of a minus x divided by a plus x. We'll label this as equation number 1. What we'll do, we'll try to simplify this expression within the parentheses by making a trigonometric transformation. We're going to consider x to be equals to a times, let's say, cosine of 2 theta. Now, when you take x equals to cosine of 2 theta, this implies that square root of a minus x divided by a plus x. So this becomes equals to square root of, we have a minus, in place of x, we have a times cosine of 2 theta divided by a plus a times cosine of 2 theta. That means we now have square root of 1 minus cosine of 2 theta divided by 1 plus cosine of 2 theta, which will be equals to the 1 minus cosine of 2 theta. That's a standard identity. We have 2 times sine squared theta divided by 2 times cosine squared theta, which gives us square root of tangent squared theta. Now tangent squared theta being a perfect square, this will be equals to tangent of theta. So that means equation number 1 now transforms to y equals to tangent inverse of tangent of theta. That means y will be equals to theta. Now we considered x equals to a times cosine of 2 theta. This would mean that 2 theta equals to cosine inverse of x over a. So since we need theta, that means y will be simply equals to 1 over 2 times cosine inverse of x over a. So we have simplified our original equation 1 to this new equation 2. It's a simplified form. So let's try to find out the derivative of 2 with respect to x. So we have derivative of y with respect to x equals to half multiplied to derivative with respect to x of cosine inverse of x over a. Now we know that derivative with respect to u of cosine inverse of u, that this is given by negative 1 divided by square root of 1 minus u squared. So we'll use this particular formula, which will give us half multiplied to negative 1 divided by square root of 1 minus u squared. The u here is x over a whole square, but we'll also need to use the chain rule, so we'll multiply to derivative with respect to x of u, which is ax over a. Right. So that means we now have half multiplied to negative 1 divided by square root of a squared minus x squared divided by a squared. We have 1 over a, which is a constant, multiplied to derivative of x with respect to x. Further simplification will now give us half multiplied to negative a divided by square root of a squared minus x squared multiplied to 1 over a times derivative of x with respect to x is 1. So this a and a gets cancelled, and our final result will be derivative of y with respect to x will be given by negative 1 divided by 2 times square root of a squared minus x squared.